Hi, in this series, we are going to do about the organic past paper questions. So, I hope you already have studied the organic chemistry portion, which is the major portion of ACE and ACE level, and the major amount of questions are being asked from this portion. So, what we are going to do, we have collected all the papers, all the questions from 2018 to 22, and we have collated in one place. Let's start this series. So the video is going to be little lengthy, uh, but we are able to solve all the questions. Let's start it. So let's start with this question. So saying uh, one molecule of ammonia reacts with one molecule of ethyl methanoate. Ethyl methanoate, the formula is given, to produce one molecule of methanamide. So it's saying HCOO-C2H5. This is going to react with one molecule of ammonia. So NH3 is reacting. So I'll write the hydrogens like this. One of the product is formed is saying HCONH2. So what will be the other product? So if I'm going to do the aminolysis, so H N H H. So you can understand this one in this way. So this H and this one is going to move out. So what is remaining? So HCONH2 plus C2H5OH. So you're going to get the another product which question is saying about X. So X will be your C2H5OH, ethanol. So that means these two options got cancelled out. So only these two options are remaining. Okay, let's see the next point, what it is saying. One molecule of methanamide decomposes on heating strongly to produce one molecule of ammonia and the other molecule is Y. So the HCONH2 is being heated strongly. So it's going to produce NH3, one product. What will be the other product? The other product, initially it is going to form HCOOH and then it's going to break down into CO, right? Carbon monoxide, right? So it's going to form NH3 and CO, carbon monoxide. So here is your product, ethanol and carbon monoxide. Okay, wonderful. Let's see the next question. What type of stereoisomerism are shown by 2,4 dimethyl hex 2-in? So first we need to draw the structure. So it's saying about hex 2-in. So we're going to draw hex means 6 carbon. So 1, 2, 3, 4, 5 and 6. And then there's 2-in if we number from this side. So 2 position there's a in and 2 position there's a methyl. So here's a methyl. 4 position. So 2, 3, 4. This is the 4 position. There's another methyl. Okay, now is there anything else? No. Now rest of the bonds we need to put hydrogen, so we are going to get the structure. So here's 1H, here's nothing, here's 1H and here is CH3. Okay, wonderful. Now the stereoisomers. So first of all, I can see this double bond, all the hands are different, so I'll have a cis trans isomerism over here based on this. So a cis trans, I'm going to get cis trans. So two isomer I'm going to get of this one. One is cis, one is trans. If these two CH3s are in opposite direction, it will be trans, and CH2 CH3, and this one is H. This is your trans isomer, and if these two CH3s are in the same direction, that will be cis. So we are getting a cis trans. Apart from the cis trans, what else we are getting? A wonderful observation is there. You need to found is there any carbon atom which is having all 4 different hands. Now I can see this carbon atom has all 4 different hands. I'd like to draw that. So one side it has CH2 CH3, one side it has CH3, one side it has hydrogen, one side it's connected with C double bond, this one, the big group, CH3, CH bond CH3. Okay, now this carbon is a chiral carbon. So it's a chiral carbon. Now once it's a chiral carbon, it's going to show optical isomerism, like enantiomer. Enantiomerism it's going to show. So cis trans isomerism and optical isomerism, both we are getting from this isomer. So option A is the correct option, cis trans isomer and an optical isomer. Okay, hope it is clear. Let's see the next one. An organic ion containing a carbon atom with a negative charge is called carbon. Okay, so carbon ion means a carbon atom will have a negative charge. For example, CH3 minus. Okay, this is a carbon ion. An organic ion containing a carbon atom with a positive charge. For example, CH3, CH2 plus. Okay. So this is called a carbocation and a carbon ion. Next, the reaction between aqueous sodium hydroxide and 1-bromobutane proceed by an SN2 mechanism. So let me just remind you what does it mean by SN2 mechanism. So SN2 is a mechanism, it happens the backside attack. So 1-bromobutane. So let's draw it 1-bromobutane, CH3, CH2, CH2 and CH2Br. So now here it is going to react with sodium hydroxide, aqueous sodium hydroxide. So which minus is going to react here from the backside and the bromine is going to move out. So it's going to form CH3, CH2, 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 OH. Oops. Yeah. So it's going to form OH. Right. Now let's see the options. What options it's saying? Attacked by so what is the first step of the mechanism? Attacked by a nucleophile on the carbon atom with a partial positive charge. Okay, so this is a nucleophile. There's a partial positive charge, delta plus and delta minus. Okay, heterolytic bond fission followed by attack of a electrophile of a carbon atom. No, this option is not true because heterolytic bond cleavage is not happening. So the other three options is saying about the bond cleavage. So these are wrong. So the first point is the correct option for you. Okay, let's move for the next one. The compound X can be converted into compound Y in a single step. Okay, so yeah, now what could be compound X? So I can see one side there's a carboxylic acid, and one side there I can see that a ketone. So that means there has to be a double bond, and the double bond is being split up by potassium permanganate, concentrated potassium permanganate, and heat is needed. So let's join these two. Okay, and let's see what could have been my compound. So now this side we got a carboxylic acid. That means the double bond definitely contains hydrogen. Okay, so the double bond, when there's a double bond and this double bond contains two hydrogens, so the when it breaks in presence of potassium permanganate KMnO4, so this side, if it is hydrogen, it's going to form carboxylic acid, and if there's a one of the bond is connected with a methyl group, it's going to form a ketone. Okay, so that means one side carboxylic acid has formed. That means the bond was definitely a hydrogen was attached to here. So I can see my options. Look, these are the hydrogen bonds, or hydrogens are there. Okay, so all these four options have one side it has hydrogen, so it is possible for all these four from this side. Now another side there's a ketone, so that means definitely the bond has at least one methyl. So this methyl I can consider, this methyl I can consider, this methyl I can consider, this methyl I can consider. Oh, wonderful question. So now it's a confusion that which option. So all the four option has a methyl group attached to the double bond. All the four option has one hydrogen attached to the double bond. Now let's join these two by eliminating the COH and CO. Then we'll be able to find. So let's count the number 1, 2, 3, 4, and 5. So 5 carbon is there. Means the 5 carbon is forming a ring. So that means this two option got cancelled out because these two are 6-membered carbon. So let's join a 5-membered ring to make a 5-member ring, and the let's join the double bond over here and one hydrogen over here, one methyl group over here. So if this double bond breaks, this is going to form carboxylic acid, this is going to form methyl group. Now 4 position, if this is my 5 position and this is my 1 position, then the 4 position, 1, 2, 3, 4, this position there is a methyl group, okay, CH3 group. So this is my original compound which is getting break down to form 1. So let's find out which option is matching. I can find option A is matching. Okay, hope it is clear, and this is how you need to figure it out. Okay, let's move for the next and let's see what is the question saying. Which compound reacts with 2,4-DNP, phenyl hydrogen, dinitrophenyl hydrogen, but not react with toluenes. So 2,4-DNP, it is a reagent to identify a carbonyl carbon. 2,4-DNP. Carbonyl carbon means this is a test which is used for either for a ketone or for an aldehyde. Okay, so it is giving a positive test. That means definitely among these two group, one group is there. But in the next step, it's saying it does not react with toluenes reagent. What is toluenes reagent? Toluenes reaction. Toluenes reaction is the reaction with ammonical silver nitrate solution. So Ag plus, reaction with ammonical Ag plus, which is going to form silver. So it's a silver mirror test. So which among aldehyde and ketone, which one is going to give a positive silver mirror test? Only aldehyde, not the ketone. So ketone could not give the toluene state, but aldehyde can give. Now we can go for our options. So for the first option, I can see there's a ketone group, okay, but there's an carboxylic acid group, so not possible. Carboxylic acid group cannot give the toluene test. Okay. Okay, but saying does not react with toluenes. Okay, so sorry, then that means it could be a possible option like CO group is there, so it can definitely form 2,4-DNP, but COOH it's not going to reduce to the toluene reagent. Okay, let's see for the next option. There is no CO group and there is a CHO group, so got cancelled out. There is a CHO group, got cancelled out. So third group, there is no CO, no CHO. So all these three options are cancelled out. So this option is your correct option. Because CH3CO, that means the CO group is going to form the 2,4-DNP test, and COOH, this is not going to react with toluene reagent. Okay, great. Let's move for the next, which is the structural isomer and the stereoisomerism should be considered when answering the question. The following molecular formula of a compound X is C5H12O. Compound X reacts with alkaline aqueous iodide. Okay, alkaline aqueous iodide, and can be dehydrated to form 2 alkenes only. Okay, so one thing from this point you have to understand that what is the reaction says. The reaction alkaline NaOH, NaOH and I2. This is a reagent. It's a haloform reaction. It's a naming reaction, haloform reaction. So for what kind of substance the haloform reaction works? So there should be an active group. Along with that, the 3 alpha hydrogens should be there. 3 alpha hydrogens. Without that, the haloform reaction is not going to happen. So the compound says that it's going to form haloform. That means there are three alpha hydrogens with adjacent to an active group like a ketone or an aldehyde or an alcohol. Okay. Second thing, it can be dehydrated to form um, alkenes only. Now it's saying it can be dehydrated, so that means a ketone cannot be dehydrated. So definitely it's an alcohol. Okay, so an alcohol can be dehydrated. So let's just remove this ketone group and put a OH group. Okay, so it is an OH, adjacent to there are CH3. Okay, now let's find out from the structure. So which option could be a possible option? So now from the first option I can see CH2OH, and along with that there is CH and CH3. So alpha carbon do not contains three hydrogen. So one hydrogen it contains. So this option could not be a correct option. For the second one, I can see CH2, CH, and then CH2, and then CH3, then CH3. So again the two alpha position which do not contains three hydrogen. So this option also a wrong option. For the third one, I can see CH. I'm just only drawing the alpha position, CH3, OH, and then this side there is CH, and so on. So now here I can see there is an alpha position where three hydrogens are there. So this compound can be your one option for haloform one. Now the second one also I can see there are three alpha hydrogens. So this compound also can be one of your can be your answer. But which one is your correct answer? The second point is going to prove which one is your correct answer. So how it is going to prove? Let's see. The second point is saying can be dehydrated to form two alkenes only. So now let's make the formula for how it is going to be dehydrated. So CH3 whole 2, the option C I am drawing. So CH bond CHOH and bond CH3. Now if it's going to dehydrate, so it's going to form CH3 whole 2 CH double bond, sorry, whole 2 C double bond. I have added one extra hydrogen over here. It should not be. C double bond C bond CH bond CH3. So this is your one alkene, and another alkene will be CH3 whole 2 CH bond CH double bond CH2. Okay, so this is your two compounds, and let's do for this one also. So CH3 CH2 CH2 CHOH and then CH3. Now if I'm going to eliminate the water from here, CH3 CH2 CH double bond CH bond C, oops, bond CH3. This is your one alkene, and another alkene will be CH3 CH2 CH2 CH double bond CH2. Okay, so both the alkenes, both the alcohols are giving two alkenes. This is the one, this is the two, and for this one and two. Now which one is the correct option? Now we have to look for the molecular formula. So C5H12. This compound contains 1, 2, 3, 4 and 5 carbon. This compound contains 1, 2, 3, 4, 5 carbons. So now the question is saying structural and stereoisomer both needs to be considered. So these two are my structural isomers. Now from this option I can see this option will not have cis trans isomerism. Why? Because the double bond carbon having two CH3 groups. So no cis trans is possible for here, right? And the second one, this one will also not have cis trans isomerism because the other side of the hydrogen, other side of the double bond contains hydrogen. So that means it will have only two isomers over here. But here, this isomer will have cis trans. So that means this option got cancelled out. Only this option remains. So this is my correct answer. It's a wonderful question to figure it out, because there are 4 steps to figure it out. Okay, let's move for the next. Okay, so I need to clear off a little bit because less space is remaining. Okay. Okay, let's move for the next question. The next question is, volume of hydrogen measured under room conditions is produced when 0.16 gram of methanol reacts with excess of sodium. Okay, let's write the formula. Methanol, so CH3OH. Very simple. It's a mole concept question. Plus sodium, it's going to form CH3ONA plus hydrogen H2. Now we need to balance the reaction. So 2CH3OH, 2Na, this is also 2 and this is 1. So from the equation I can see 2 moles of CH3OH is going to form 1 mole of hydrogen. Okay. Now you have 0.16 gram of methanol. So that means let's convert it into mole. 0.16 divided by the molar mass of methanol is 12 plus 4. So 16 plus 16, 32. So 32, 0.16 divided by 32 moles is going to form how many moles? We need to calculate, put it in the calculator. So it's coming 0.0025 mole. So we got 0.0025 mole of hydrogen produced. Now the volume of the hydrogen gas will be, so 1 mole has the volume equals to 24 decimeter cube at room temperature pressure. So 0.0025 mole will have 24 into 0.0025 will be equals to, so let's multiply it into 24. So it is decimeter cube, but my answers all are in centimeter cube. So I'm getting 0.06 decimeter cube, that means 60 centimeter cube. So here it is, your answer or answering. Okay, we can move for the next question. Next question is saying, compound X produces carboxylic acid when heated under reflux with acidified potassium dichromate solution. Okay, so from this point we can understand that the compound might have a CHO group or a primary alcohol group which is getting oxidized to form COOH group. Okay, in presence of the oxidizing agent potassium dichromate and H plus. Compound X does not react with sodium metal. So compound X does not react with sodium metal means it do not have OH group, right? OH group can react with sodium, but CHO group cannot react. So that means definitely it's a CHO group. Okay, then let's see the options. So first option only we are getting propanal, means CH3, CH2, CHO, propanal. So this option could be my correct option. Let's see the other options also. So propanone, it's a ketone. Ketone is not easily oxidized by to form carboxylic acid. Last two options are alcohol, so got cancelled out. So only option A is my correct option. Let's see the next question. A reaction occurs when a sample of 1 chloropropane is heated under reflux with sodium hydroxide in ethanol. So you have to see the reactant. What is the reactant? Say sodium hydroxide in ethanol. It gives an elimination reaction. So let's draw the structure of 1 chloropropane. So it's propane, that means 3 carbons are there. Chlor. Okay, now it's being refluxed with sodium hydroxide NaOH in ethanol ETOH. So this is a reagent which does the elimination, beta elimination. So beta position, there's a double bond over here, so it's going to form a double bond, CH double bond CH2. This is your product. Okay, plus HX. Okay, let's see. So it's an elimination reaction, so these two options got cancelled out. Elimination. Now the propene is a product, so option B is the correct option. Okay, subscribe my channel for such more videos. If you want one-to-one tuitions or batch tuitions, please follow the next screen. Thank you so much.